Video.
Ay, sorry.
Okay, so paki-request so that will be on February 17. Okay, so again para tayo. Next meeting. Mr. President, please tell me sa kung ano okay, pasok tayo make a class. Okay, so kahit 3 hours lang. I-browse ko na klasa, so please take a picture na lang. Okay. Okay, listen now. Okay, listen. Okay, so class, analytical chemistry is all about reactions. Ano po, no? Sabi ko sa inyo, noon pa man, dalawang subjects natin sa analytical chemistry. Qualitative at saka quantitative analysis, no? Okay, yung ibang topics ng qualitative chemistry or analysis, I will discuss it in the laboratory, while some in the lecture. Katulad na rin pa itong chemical kinetics, kaya i-discuss ko sa lecture. Okay, so again, analytical chemistry is all about reactions, no? Okay. While we are performing qualitative analysis class, no? Okay. So you would expect that some of them will give immediate results. Others will give case results after a few minutes or even hours, no? Okay. Kanina chinek ko kanina, no? Okay, so kung meron pa tayong mga pang-test, mga qualitative test dyan sa ating ano, no? So meron naman akong nakita dyan. However, no? However, we will start first, no? Okay, so with simple qualitative analysis. Okay? And when we speak of reactions, yung mga reactions na tinutukoy ko, class pinag-aaralan po ito, no? Para mas maintindihan natin, mas maunawaan natin mabuti ang mga reactions na magaganap sa ating quantitative determinations, dapat alam natin, okay? So kung gaano kabilis or kabagal ang reactions nila, so that alam natin kung gaano katagal or gaano kabilis ang iintayin natin. Ano po? When we speak of kinetics law, we are referring to the study of how fast or how slow the reaction is, no? Gaano kabilis, gaano kabagal ang reactions, okay? Pagka pinaghalo natin yung mga reagents na gagamitin natin sa pag-analyze, okay? Yan ang inaaral sa chemical kinetics. Supposedly, ang unang topic natin ay equilibrium, no? However, ang equilibrium kasi, ang prerequisite ng equilibrium is kinetics. So you have to study first kinetics before you can understand equilibrium. Because everything in analytical chemistry, be it qualitative, be it quantitative, is all about equilibrium. And before we discuss what equilibrium is, we have to discuss first what kinetics is so that alam natin, okay, or so that mas madali natin ma-appreciate ang equilibrium. Maliwanag po. Again, this is lecture muna. Maya-maya na lang ng konti yung natitirang topic natin sa laboratory. Listen. Okay, so that is, okay, so our topic last time, we talked about basic solutions as well as stoichiometry. And hopefully today, as we discuss chemical kinetics, we will be able to distinguish every aspect of chemical reactions and apply it in laboratory settings, no? Okay, so para class, alam natin, ang ating patutunguhan sa ating ginagawang experiment, no? So dapat alam natin yung mga kinetics na yan. So under this topic, we will be discussing reaction rates, factors affecting reaction rates, concentration and rate, so the changes, no? And etc. In our experiment number 12 last semester, I hope you can still recall, no? Okay, so we have performed an experiment regarding kinetics, di ba? Yung pagkarami-rami natin mga chemicals sa ginamit, na pinaghalo-halo natin, okay, so tapos inurasan natin. What we did there is actually kinetics. Kaya lang, we don't have that much time in inorganic chemistry, no? So to discuss what kinetics is, no? Kasi may organic chemistry na kasama. Kaya dito natin siyang i-discuss. Okay? Now listen. As we discuss chemical kinetics class, So we will, okay, be encountering these different terms, okay? I hope, okay, but I hope before we discuss everything, no, maintindihan muna natin ang mga terminologies na yan so that mas madali nating maintindihan ang chemical kinetics. Yun ang guys. So sabi, pag sinabing chemical kinetics, rate, bilis or bagal, in which a chemical process occurs, no? Yung nga sinabi ko kanina. Okay, so this is an area of chemistry so that deals with the study of the speed or rates of reaction. Okay? So that is chemical kinetics. Now, aside from that, no, so please take note, okay, that in chemical kinetics we'll be discussing reaction rates. O pag sinabi natin reaction rates, okay, hindi ko na ulit-ulitin later on. Pag sinabi natin reaction rate, this is how we measure rate. Paano natin sinusukat ang bilis ng reaction. Yan yung tinatawag natin reaction rate. Now, we will also be discussing rate laws. Okay? So, pag sinabi natin rate laws, this is how the rate depends on the amount of the reactants. Okay? So, class take note, amount of the reactants. Okay? Ang bilis daw ng pagkakaroon ng reaction ay nakadepend, no? Okay, so on the amount of reactant. And that is expressed, no, in rate law. Okay? Now, when we speak of integrated rate law, ma-encounter din natin yung kanina. Pag sinabi ng integrated kasi, ang ibig sabihin noon, magkasama na, pinagsama-sama, pinaglabo-labo, di ba? Pinagmekos-mekos na. So, yung ibig sabihin ng integrated, right? Okay, sige, saan man napunta? Sa pagkalit ng mekos-mekos na yan. Great ba yun? Okay. Or invento nyo lang class yun, ng mga millennial. Okay, so integrated rate law, okay, so this will tell us, or this will show us how to calculate the amount left or time to reach a given amount. Ayan, no? Para hindi na tayo mag-iintay, pwede natin hintayin kung, pwede natin i-compute kung gano'ng katagal mag-uukur ang reaction. Para hindi na kayo nag-iintay class, di ba? Basta alam natin ang mga concentration, kaya diniscuss natin ang concentration class, no? Pwede natin malaman kung gano'ng katagal or kabilis ang reaction. Okay? So kasi class, pag hindi natin alam yan, okay, so baka mamaya, sabihin natin, walang ma-reaction, no? Okay, yung pala, kailangan lang ng konting oras pa so para makita natin ang reaction. Baka mamaya pagtapon nyo na, okay? So yung inyong ine-experiment, yung pala naman mabagal lang ang reaction, okay? So para hindi tayo, okay? Para hindi tayo masayangan ng mga chemicals, no? So pwede natin i-compute yun, okay? So you will also be encountering a Arrhenius equation, okay? So in our chemical kinetics, ang sabi dito, so this shows us how rate constant changes with temperature. Iba-iba daw, okay? Iba-iba daw yung mga rate na yan, so depending upon the temperature. Kaya nga class, so sabi ko, gagamit tayo ng water bath, okay? So most of the time in our experiments, kasi may mga experiment na kailangan pabilisin natin ang reaction para hindi naman mag-take forever, no? Ang ating experiment. Take note, wala naman forever, di ba class? Okay, so kaya dapat computing na natin. Ganun din kayo class. Pwede yung computing kung hanggang kailan lang kayo nag-jowa mo, no? Or as long as alam mo, okay, ang gusto ng bawat isa. Mamaya malalaman natin yan. Ipapakompute ko sa inyo kung hanggang ilang araw lang kayo tatagal. Okay. And of course, the mechanism. Ayan ang class, no? Okay, so class, ang isang reactions, hindi yan basta-basta nagre-react. May step 1, step 2, step 3 yan. Okay? Itong mga steps, okay, na pinanggagalingan ng mga reactants natin, bago sila tuluyang mag-react, no? Yan yung tinatawag natin na mechanism. Kayo yan, parang kayo yung class, no? May mga lalaki, pag yan ang liligaw, may step 1 muna, may step 2, step 3. Yun yung mechanism ng panliligaw ninyo. Ano po? Ganun din naman ang mga babae bago sumagot, no? Okay, may step 1, step 2, step 3, din nakaartihan, okay? Okay, so that is mechanism. Yun yung tinutukoy natin na mechanism. May tanong po ba, class? Sige. Now, listen. In most instances, class, no? Kasi di ba, Okay, so yung ating pinag-aralan sa concentration, isusulat pa natin, halimbawa, 0.5 molar, o kaya 0.5 normal, okay? However, in the chemical kinetics class, no? So sometimes, once you see a bracket, no? Okay, so containing a certain number, no? Okay, so say for example, that is A.5 and ACl, no? Okay, so what we are referring to whenever you see a bracket, in terms of chemical kinetics is the concentration. Okay? So pag nakakita kayo ng brackets sa isang chemical kinetics, ang tinutukoy lang nun ay konsentrasyon. Ano pa? Concentration. Okay? So that is another thing is that you will encounter in the discussion of chemical kinetics. Okay? So say for example, okay, so you have there the reaction A. So to produce B, isn't it that A is your reactant, so B is your product, di po ba class? Okay, so ang sabi, so we can actually measure, okay, so two ways, okay, in a chemical reaction. So pwede nating sukatin ang dalawang bagay pagdating sa chemical reaction. Pwede nating sukatin yung pagkaubos ng A, yung bilis ng pagkaubos ng A. Kasi di ba ang reactant, ibig sabihin sila yung inuubos. Sila yung hino-consume, isn't it? So, in a chemical kinetics, pwede nating sukatin ang bilis ng pagkawala ng A or ng ating reactant, no? Okay, or in English ko lang, is speed at which the reactant disappear, no? Okay, so pwede rin natin i-compute kung gaano kabilis ang pag-appear ng product ninyo, no? Or ang pag-produce ng product nyo, pwede din natin ma-compute yan in a chemical kinetics. Okay? Now listen. In a chemical equation, most of the time, isang arrow lang ang nakikita nyo, di ba class? Pero actually, sa totoong buhay, lalo na pagdating sa qualitative analysis, no? Okay, so it is a must that our reaction must go the other way around as well. Okay? Kaya, minsan, imbes na isang arrow lang, so you will encounter a reverse arrow in a chemical equation when it comes to analytical chemistry, no? Okay. So medyo one step ahead ang analytical chemistry. Kung sa inorganic chemistry, isang araw lang, ngayon dalawang araw na ang makikita ninyo sa isang chemical equation. Papunta at pabalik. Is that clear? And whenever we see that in an equation, okay, so then that means the reaction is reversible. Okay? So again, huwag tayong magulungan kung nakakita tayo ng reaction na ganito, ipinapahiwatig lang nito na ang reaction nyo ay reversible. Ibig sabihin, so pwede siyang bumalik doon sa dati niyang anyo. Maliwanag po. Okay, so that is what the double arrow means. Okay? Ayan na. Okay? Puro computation ito class, ha? Please bear with me. Okay, so kasi lahat ng topic sa analytical chemistry ay computation. Okay, listen. So in order for us, okay, so to compute the rate or ang bilis ng reaction ninyo, then this will be our general formula. No? Okay. So ang sabi dyan, we measure the rate, ang bilis, in terms of change in concentration per unit time. Di ba class? Pag sinabi nating bilis, may time na involved, isn't it? Okay, so ang bilis ng pagtakbo nyo, okay? So di ba, mini-measure natin kung gaano kalayo ang natakbo nyo versus the time, okay? So ganoon din ang bilis ng inyong chip na sinasakyan, kaya lagi yung kinakatumilan sa akin yan. Ang bagal po kasi yung chip, no? Okay, so may unit of time palagi, ang bilis, ang reaction rate. Is that clear? Now, you look at that general equation, okay, so when it comes to computation of the rate, so as you notice, okay, so the rate is equal to, again, that is pronounced as delta, change in concentration of A. Again, if it is in bracket, that is in terms of concentration. Maliwanag po, per change in time. So again, this is pronounced as delta, and this means change. Maliwanag po. So that is why, as you could see over there, the most common units daw na ginagamit dyan ay, okay, molar per second. Okay? So, and where you can see there that molarity is simply moles per liter. Alam na natin yan. So most of the time, it is a molar per second ang ginagamit pagdating sa rate unit. Maliwanag po.
Yes.
Okay. Sige, next. Saan paano po yun? Yun lang po bang reactant ang M1? Okay. So, ay paano po yung product? Paano namin yung i-express? Ano? Okay, sige. So again, so we have the equation A will produce B, wherein this is your reactant and this is your product. Ano pa? Na? Okay, so please remember that the reactant is yung nauubos or siya yung nakoconsume. No? Okay, so ito naman ang napoproduce. Okay, so this one is produce kasi nga product siya. So how are we going to express the rate of the reactant and the rate of your product? No? Okay, so again, so when you speak of rate, no, ito yung general formula niya, class. Okay? However, take note, since ang A, ang reactant ay nauubos, that is why, if you are asked to compute for the rate of the reactant, it must be preceded by a negative sign. Is that clear? So that is the negative change in the concentration of your reactant divided by the change in time. Maliwanag po? Bakit may negative ang reactant? Why? Okay. Hindi pa ito ano ha? Oh, sige. Bakit may negative ang reactant? Nauubos siya, kaya may negative yan. Ano po? Samantalang yung B, so salagay natin dito rate of the reactant. Samantalang yung B, so which is your product, ay walang negative, okay? Walang negative sign. It is simply the rate or the change in the concentration of B, okay, so divided by the change in time. Okay? Tatandaan niya class ha? Ang mga reactants may negative dahil sila ay nauubos. Ang product walang negative dahil sila ay napoproduce. Is that clear? Okay. Eh paano sa kung hindi ganyan yung equation? Paano pagka marami? Kasi A and B lang yan sir eh. Tsaka paano pagka may balance equation? Okay. So, paano po namin siya gagawin? But before that, no? So, para mas maunawaan natin, no? Please take note, okay, so the different factors affecting reaction rate. Para mapabilis or mapabagal natin daw ang mga reaction, kailangan natin isa lang ang mga sumusunod. Unang-una yung temperature. Take note, mas mataas ang temperatura, you will expect mas mabilis ang reaction. Bakit? I can actually explain it using two theories. Okay? Meron tayong tinatawag na collision theory at meron tayong tinatawag na kinetic theory. Okay? Bakit bumibilis ang reaction pag tumataas ang temperature? Unahin ko na muna yung kinetic theory. Listen. Class, di ba pag sinabi natin kinetic energy, so that is the energy in motion. Di ba, class? Okay. Pag kayo, sinalang ko sa apoy, kayo ba, class, magiging steady lang kayo?
Hindi!
Di ba maggagagalaw kayo? Di ba, class? Okay. Pag maggagagalaw kayo, o hindi naman yung gaganyan lang, pero hindi kayo kikilo sa isang lugar, no? Pag magagagalaw kayo, tumataas ang inyong kinetic energy. Isn't it? Kasi nag-motion siya. Meron kayong motion. Okay? At since nagiging mataas ang kinetic energy ninyo, no? Okay, so ang bilis, no? Ang bilis ng reaction na nagaganap. O, di ba? Sinulong kayo, okay, so tumalong kayo kaagad, ang bilis ng reaction. Isn't it? So that is how the kinetic energy, okay, so explains why temperature can speed up reaction. Maliwanag po. And of course, no? Okay, so meron pa tayong tinatawag na collision theory. Okay, so pagka kayo nagagalaw sa isang room na nasusunog, okay, ang dami natin nagagalaw kayo, the tendency is that magkabanggaan kayo class, diba? So there is a tendency, very big tendency for you to collide. Is that clear? O diba, lalaki, babae, pagka nag-blend ng ganyan, so bilang sila kakaroon ng spark sa isa't isa. Nai-inlove ka agad. Okay, yeah. Ang baby ka agad. Okay, so pag-iing aside class, no? Pag iinit ang isang bagay, the molecules, okay, so tend, okay, so to be in motion. Marami silang kinetic energy, kaya mabilis na nagre-react. At pagka sila ay magulo, so chances are magkabanggaan sila sa isa't isa. So pag mabilis ang galaw mo at bumangga ka sa ibang molecules, no, nagkakaroon tayo ng mabilis na reaction. Naintindihan niyo ba ibig ko sabihin na?
Yes.
Diba? Okay, pagka kayo mabagal, mabagal ang reaction. Pagka hindi mataas ang temperature nyo, mabagal ang galaw ninyo. Isn't it? So that is how it is explained by collision and kinetic theory. Second, class, ito ginawa natin last time ito, no? So sa ating experiment, although hindi natin hinabakan ang discussion sa because of lack of time. Pero this is now the time for me to explain that another factor is the concentration of your reactant. No? Okay. So mas marami kayong idadagdag na reactant, okay? So most probably, mas mabilis ang magiging reaction nyo. Maliwanag po. Okay, so kasi nadadagdagan na nadadagdagan. However, since meron tayong limiting reagent, no, dapat pag dinadagdagan natin yung isang reactant, yung isa dadagdagan din natin. Sabay natin dadagdagan, so para bumilis ang reaction. Is that clear? Okay, kayo man class, no? Okay, so kayo man, halimbawa, yung nililigawan nyo, pakipunta, no? So, hahanap kayo, mga lalaki, hahanap kayo ng mga kakampi nyo, no? Okay, hahanap kayo ng kakampi nyo, so para mapasagot siya. Parang ganun, malayo yata ang example ko. Well, anyway, no? Dumami kayo kasi, no? Dumami na nililigaw sa isang babae. No? So, para sa'yo, therefore, mas mabilis yun, di ba? Kasi malagi ganun ang aking example. Laging love life nyo, no? Hindi naman love life ko, no? Wala kasing kwenta yung love life ko.
Kwento ko naman dyan.
And then we also have catalyst. I hope you can still recall that catalyst is anything that can speed up or slow down the rate of reaction. No? Kasi class, may mga reactants na bago sila mag-react, no? Kailangan mo muna, okay? So, alam mo munang i-energize sila, no? Okay, kaya nandiyan ang catalyst, okay, ay para dagdagan sila ng energy. So that, okay, so yung kanilang reaction ay maganap. Maliwanag ko? Parang kayo rin yung class, no? Okay, so, paano na kayo mag-isip sa catalyst? So, ayoko na. Okay, so kasi puro love life lang ang pinagsasabi ko. Okay, so then, class to, siguro naaalala nyo pa, no? Okay, so nag-experiment tayo, no? Yung may zinc, mosi, at saka zinc dust. Diba? Yung malalaking piraso ng zinc at saka yung dust na zinc. At ang sabi natin, mas mabilis yung dust. Kasi pino siya. Okay? Class, pag pino ang isang bagay, mas maraming area niya ang exposed dun sa iyong reactant. So, and therefore, mas mabilis siya nagre-react. Kasi yung isang buong ganyan, eto lang ang exposed. Samantalang kung dinurog natin, maraming exposed sa kanya, no? So, kaya nga tawag dyan ay bread and butter theory, no? Okay, so kasi just imagine, okay, yung bread ninyo, no? Okay, so pagka pinira-pirasan yung bread ninyo, at tinagyan ninyo ang bawat isang part ng bread ng butter, no? Okay, so di ba mas masarap yun, no? So mas mabilis, no? Malasahan ang butter, okay? Naintindihan niyo pag ibig ko sabihin, okay?
Yes, po.
Except, kumpara nyo naman doon sa isang bread lamang, okay? So yung ibabaw lang ang nalalagyan ng butter, o hindi ba? So parang hindi rin naaarap yung nasa loob. Is that clear? Kaya bread and butter theory. And of course, okay, so pressure also affect, no? the rate of reaction. So since, okay, so they will increase, okay, the collision. So usually this happens in a gaseous particles, no? Okay, pagka ang isang gas, okay, so in-applyan natin ng pressure, okay, so what will happen is that tataas ang kanilang kinetic energy and at the same time magkakaroon mabilis, okay, na collision and therefore mas mabilis sa reaction, okay, among gases. And those are the different factors affecting, okay, so the reaction rate. Okay. I-apply na natin sa totoong buhay yung mga sinabi ko kanina. What if kung meron na tayong totoong equation? What if kung meron na tayong ganito? Kasi kanina A and B lang. Eh what if kung ganito na class, no? Okay, anong gagawin natin dyan? Okay? Now you look at their coefficients. Balance ba class at first place balance ba ito?
Yes.
Okay. You look at the coefficients, no? Okay. So this is understood to be 1. Okay. Now, as you look, in every 2 moles of N2O5, may 4 na moles of NO2 ang napoproduce at 1 mole na oxygen. Is that clear? Okay. In every 2 moles of N2O5, there are 4 moles of NO2 and 1 mole of oxygen produced. Is that clear? Okay. Well, ano naman sir ang kaugnayan niyan sa reaction rate, no? So nung mga coefficient na yan. Okay. Now listen. In the computation of the chemical rate, please take note, okay, that the change in concentration of the reactants or products is inversely proportional to their stoichiometric proportions, no? Okay. So ibig sabihin, whenever they react, iyang mga nakikita ninyong coefficient daw must be taken inversely, meaning to say dapat kung sila ay numerator, i-inverse lang natin, gagawin natin silang denominator. Isn't it that it is understood that 2 has a denominator of 1, isn't it? Okay, babaliktad lang daw natin. Okay, so kaya magkakaroon siya ng 1 over 2. Okay, so 1 over 4, and this is still 1 over 1. Inversely. Maliwanag po?
Yes po.
Okay, so again, in chemical reaction, in chemical kinetics, no? Okay. So those coefficients that you can see must be taken inversely. Kaya naman class, in that particular reaction na nakikita natin, let me just rewrite the equation. N2O5 will produce NO2 nga ba yung plus? Yes, NO2 plus oxygen, no? Okay, so this is 4, this is, ilan na ba ito class? So this is 2, this is 4, and this is 1. Okay, so kaya naman as we apply itong natutunan natin kanina class, no? Okay, so as we apply this one, in an actual equation, we have, okay, so to take into consideration ang mga coefficient in the balance equation. Maliwanag po. At since sinabi na inversely dapat sila, kaya if ever I ask you to write down the rate formula of each of this, you will follow this one class. However, we have to take into consideration their coefficient. Maliwanag po. And remember, it is inversely. So therefore, for the rate of N2O5, okay, we will follow this one. This is a reactant, kaya dapat may negative tayo. The change in concentration of N2O5, can you follow?
Yes.
Susundan lang natin to class sa susundan. Kaya lang sabi natin, meron siyang coefficient na dapat inversely. Kaya yung coefficient niya, ilalagay natin sa ilalim. Can you follow? So, the times the change in time. Did you get it? Oh, sige. Ano yun?
Pwede mo po ulit nung
Ano yun?
Pwede mo po ulit.
Sige. Remember, class, ito yung rate sa reactant, may negative, isn't it? Ito ang expression ng rate sa product, walang negative. Isn't it? Okay. Pagka kayo nakakita, kasi ito class kami na hypothetical equation to. Isn't it? Okay, so hindi totoong equation. Ay, paano pag totoong equation na? No? Okay, paano natin isusulat ito sa totoong equation? Isn't it? Okay, so para maisulat natin yan, susundin lang natin ito, class, ha? Susundin lang natin ito. Can you follow? Pero, we have to take into consideration the coefficient. Is that clear? Ang coefficient, according to what we have discussed earlier, sa ilalim ilalagay. Sa ilalim. Maliwanag pa?
Yes.
Okay. You look at this. Sinundan lang natin ito, class, ha? Sinundan lang natin ito dito. Reactant kasi ang N2O5, isn't it? Kaya lang, ang pinakaiba lang, may coefficient kasi ito. At ang coefficient sa ilalim inilalagay. Sinundan lang natin ito. Maliwanag po. Yes.
Ano po yung sa number, yung 1 po, sa po?
Sige. Dito muna tayo. Okay? Next na. Okay. Sige. Punta na tayo ha. Okay na ba tayo sa N2O5? Alam kung bakit negative?
Opo.
Reactant. Naku paano yung kaya yung dalawa? Yung dalawa naman. Yung dalawa parehas product. Ano po? Okay, NO2. Okay. May negative ba? Okay. So therefore, there you have it. Siyempre ilalagay na natin yung totoong pangalan niya, no? Okay, kami na kasi bilang. Kasi hindi totoo yun, no? Hypothetical lang yun. Ito totoo na. May coefficient na 4. Saan ilalagay yung 4? Okay, so tapos, delta T. Isn't it? Ito yung tinatanong niya. Paano kaya pag 1? Sige, dikta. Ano ang rate ng oxygen? Product ang oxygen. Delta O2, very good.
Over delta.
Okay, syempre, yung 1 understood na yon. So kaya, pwede ito na lang. Actually, natin naman eh. Okay. Sige.
Pero yun na po yung
Ano yun?
Yan na sir, wala nang iba.
Ay, oo. Yes.
Sir, paano may sobrang haba?
Ito, meron tayo. Kunwari may sobrang haba. Ako, ito sobrang haba. Yan na. Pag sinabi ko sa test, okay, so write down the formula of rate of each of the reactant and products. Ito lang ang gagawin natin. Ano po? Sabi niya, paano daw pagka napakarami? Sige, ito napakarami nito, ha? Okay. Apat na to. Pero ito general lang class, no? Pagka ganito tayo nakikita natin, huwag kayo matakot. Ganun lang, no? Same lang din. Sige nga, yung A, paano yan?
Rate.
Rate ng A. Negative 1. Okay, change in the concentration of A. A ang kanyang coefficient, kaya may A na mali. Isn't it? General yan, general. Yung B. Negative din. Oo. Yung maliit na B coefficient yun. Yung C, paano kaya? Positive. Wala nang negative, ha? Yung D. Okay, wala nang negative.
Sir, paano pag pagano?
Okay. Sige, tama siya. May point siya. Pag may sinabi kasi, usually pag walang nabanggit, ang susundin yung pangalan. Okay? Yung pangalan. However, pag sinabi sa equation, taking into consideration the reverse equation. That is a time, yung reverse ang susundin nyo. Ito na ang reactant at yun na ang product.
So, kung papalitan
Basta
Yes.
sabi yung arrow yung reaction.
Yes. Pero pag walang nabanggit,
Wala
ito lang.
reaction.
Okay? So, ito lang.
May pataas. Sir, pataas.
Walang patakas. Ang mag-compute na tayo.
Sir, kailangan talaga yun. Sir, this week.
Okay, mag-compute na tayo. Okay.
Pero parang ko ganun lang.
Oo nga, ganun lang.
Ganun lang, kasi may number na. Sir, ba't may number na?
Oo nga, ganun lang. Eh, parang natin yung apply ko walang number.
Sir, dapat doon ka lang. Sir, balik ko na lang doon. Ganun lang. Yun na lang po.
Sige. Okay, so let us have that. Okay? Pag kayo magalala class, pagdating naman sa mga examples, tatalihan ko lang naman ang equation nyo. Ano pa? Okay, neutralization of phosphoric acid, H3PO4. Okay, so using istanic hydroxide, SNOH4, will produce, okay, so SNPO44 and water. SN3PO44 plus H2O. Siyempre, mahirap na ibibigay ko sa inyo kasi pagdating sa test, mani-manina lang. Ano po? Okay, sige. Okay, ayun ang tinatanong. Write the correct rate of reaction formula of all reactants and products. Ibig sabihin, ang sasagot natin sa letter A ay ito. Is that clear? Sige. Pero bago natin masagot yung letter A, dapat balance muna siya. Class, di ba class? Sige nga, paano natin ipabalance? Dikta na nga lang. Okay. Sige, isa-isa lang nga. SN, we have H and oxygen. Okay. So we have there 1 and we have there 3. Can you follow class? Okay, what do we do? Okay, put 3 over there to make SN balance. Okay, so how about your P here? 1. Over there we have 4 to balance. Okay, so you will put 4 over there to make P balance. Can you follow? Okay, so oxygen here is? Tama ba? 16 nga ba yan? Here is? 12 ba yan? Can you follow? 28 ba yan? Uy! Here is? Ilan ang kulang para maging 28? Okay. Ganun ba yun? Okay. Sige. 28 na ba? Okay. So, sige, oxygen naman. Oo. So, itong example, ito na yung mahirap. Para pagdating sa test, madali na yan. And don't you worry, minsan nagbibigay na ako ng balance equation. Sige, bigay ko na lahat pati yun. Our oxygen, this is? Ay, oxygen pala yung binalas natin kanina. Ano ba yan? Okay, so oxygen yung kanina, no? Hydrogen naman. So this is 12. And this is 12. So that is 24. Isn't it? Ay, di ba? 24. Balance ba? Yes! Okay, sige. So therefore, you look at the coefficient. You look at the coefficient. Okay. We have therefore 3, 1, 12. Isn't it? Okay. So if we will ask for the rate of H3PO4, the rate of SNOH4, the rate of SN3PO44, and the rate of water. Okay. Sige. Rate of phosphoric acid. Negative. Delta. concentration of H3PO4. Can you follow?
Yes, po.
Ano yung nasa ilalim?
Four.
Okay. Change in time. Okay. How about SNOH4? Negative delta SNOH4. Can you follow? Divided by okay. Can you follow? How about SN3PO4? Okay, SN3PO4 divided by delta T. One lang to, di ba? Okay. And then finally, yung water, how are we going to do that? Delta H2O divided by yes! One letter
Yan pa lang nakakapagod na.
but it's exciting, isn't it?
May ganyan man sa.
Okay, plus 100, pero 100,000 ang
Mabalik sa 5 minutes.
wala. Wala nang break kasi tapos ang break nyo.
Parang kailangan ng tabi.
Na? O sige, napagkating ko lang kayo. Okay. Next! Let us have letter B. At the beginning. Anong ibig sabihin nun?
Simula. Isa.
Very good. At sa simula,
May
may oras ba?
Wala po. Wala.
Kaya sa simula, T is equal to 0. The initial time is 0. Ah. 12.24 moles per liter. Remember that is molarity, isn't it? Moles per liter. A phosphoric acid was present. Okay. At T0, the molarity tau is 12.24 molar of your phosphoric acid, H3PO4. Okay. Next. Determine the rate of phosphoric acid consumption in molar per second. Oh, okay, so then that means we are asked to determine the rate. H3PO4. Alam mo ang formula? Ano formula? Oh, ito ha? Okay, so this is being asked. Is that clear? Okay. If after 3.76 minutes, naku, may panibagong time, anong ibig sabihin nun? T2. 3.76. Or in other words, this is initial, so this is final, ha? Okay. Wala namang problema doon kung 1 or 2. Okay. So that is minutes. Can you follow?
Yes.
However, as you could see, class, ang hinahanap sa atin na rate is molar per second. So therefore, you have to convert it first into second. Can you follow?
Yes.
So how many minutes are there in a second? Or how many seconds are there in a minute? Ang gagaling, no? Okay, so 1 minute, 60 seconds. O, ilang seconds? Ilan?
225.
225.6. Ganun. Okay, sige. If only 7.68 mole per liter phosphoric acid present. Ibig sabihin pala, ang initial concentration ay 12.24. Can you follow?
Yes po.
Ang sabi only, may natitira daw. So, ibig sabihin, sabihin, ang final concentration ay 7.68 molar. Can you follow?
Yes po.
Okay. Yes. Alin? This is the unit na hinahanap. Molar per second. Yes. Okay. Now listen. When we say change in concentration of phosphoric acid, that means final concentration minus initial concentration. Did you get it? Change kasi. Pag sinabing change, na bago. Correct? Ang formula ng change ng concentration ay initial concentration minus, final concentration minus initial concentration. Or should we say, so concentration of phosphoric acid final minus concentration of phosphoric acid initial. Did you get it?
Yes.
Okay. So change in concentration of phosphoric acid is that. Now, kung nakikita niyo sa ilalim, mayroon din change, isn't it? Change in time. So because change in time, delta T is equal to the T final minus T initial. Isn't it? Okay. Yes. Can we now substitute? What is our final time? 5.6 seconds. Did you get it? And what is our initial time? 0 seconds. So therefore, the change in time is still 2 to 5.6 seconds. Did you get it?
Medyo mabilis po.
O sige, mabilis. O sige. Pero nasundan class? Itong mga change na yan, may formula yan. Final minus initial. Did you get it?
Yes po.
Yan, may mga triangle na yan. May formula yan. Final minus initial.
Sir, ayun na po yung sagot sa akin.
Hindi pa, wala pa tayong sagot sa letter B. Kinakompute pa
So
lang
yung
natin
ano
yung
pa lang
change.
po yan, substitution pa lang po.
Yes. Okay. We are just computing for the change. Wala pa tayo sa rate. Change pa lang ang kinocompute natin sa change. Now let us compute for the change in concentration of phosphoric acid. What is our final concentration?
7.68.
Okay. And what is our initial concentration?
7.24.
And this is how many?
Negative.
Definitely negative yan, isn't it?
Yes po.
Negative what?
4.55.
4.55 molar.
So pwede po yun.
Yes. Hindi pa. Hindi pa.
So isa-substitute pa yan.
Isa-substitute pa yan.
Okay. Okay na ako. Kasi negative ako.
Sige.
Sir, parang kailangan ng payat.
Ay, ganun talaga ang analytical chemistry. Pag hindi mahirap ang analytical chemistry, ang tawag lang doon ay arithmetic. Ha? Hindi ha? Sige. Pakidikta ang na-produce nating formula para sa rate ng phosphoric acid. Pakidikta. Negative.
Negative 4.55.
Yun po ang formula. Delta concentration of phosphoric acid divided by 4 delta T. Did you get it?
Oh.
Ano ang value ng change in concentration of phosphoric acid? Negative 4.5. Did you get it?
55.
And 55. Okay. For 56 na daw kasi in-round off na. Sige, okay lang. Okay. 55. Sige, sige, 55. Okay. Sige na, sige na. Okay. What is the change in time? To 25.6 seconds. Isn't it that this is positive already? Yes. Okay, what is the answer? 0.00. Joke lang.
Sir, ano?
56 din pala.
Oh, sige, 4.56 daw. No problem, class. No problem. Ganun talaga mga rounding up. Okay? Oh, sige. Oh, ilan siya?
0.202.
0. Isa lang ang 0.
Yes,
2,
202.
0, 2. Molar per second. And that is the answer for letter B. B pa lang, yes. B pa lang. Wala pa, B pa lang.
Sir, pag nagsagot na kami ng quiz,
Yun?
paper kanina paper.
Ay, nawala daw yung 4. Teka muna, class. Okay, nawala daw yung 4. Pakicheck. Okay. Sige, pakicheck. Tinanggal nyo yung 4. Pakicheck.
0.080.
0.0. 0. 5, 1 molar per second. And if I ask for a scientific notation in 3 decimal and 3 significant figure, what would it be? 5.11.
11.
Kasi 0.5 sa akin, di ba? Okay, times 10 to the negative 1, 2, 3 lang. Okay. Molar per second. O tama nga naman siya. Thank you, no? Huwag niyong kakalimutan yung mga nasa denominator. Okay? Ha? Ano yun?
Sir, pag nagsagot,
B pa lang.
sir, pag nagsagot ang kami ng quiz next week, sa Manila paper.
Ma'am, sir, nire-record niyo po ba ng scientific notation palagi yun?
Ayun din.
Okay lang kayo kung hindi naman.
Okay. So just in case.
Sir, pag daw po yung
Kaso nag-round, ano, ba't pa yun?
Kasi sabi ko 5.105 daw din.
5.053.
053. 5.053. Ganyan.
Yes.
Sige. Okay.
5.
Ganito ha. Pare-parehas na. Sige. Actually, supposedly, but I will not require. Yes.
yung pa rin lalabas.
Pero may lumalabas sa phone ko pag kinakilin na dito.
Okay, so next. Can we proceed to letter C?
Sir, wala naman kami choice eh.
Of course, wala kayong choice. Okay. Sabi, what would be the rate of formation? Okay. So again, ang tinatanong, rate daw ng formation ng stannic phosphate. So SN3, PO4, 4. Pakidikta nga sa akin ang formulang na-derive natin kanina para sa rate ng SN3PO4. Babasahin mo.
SN304.
So, delta SN3PO4
Over delta.
1 lang ang coefficient niya, di ba, class? Again, pag sinabi natin delta, so that means is equal to the concentration final minus the concentration initial. And when we change, yes. So this triangle here is change, no? Okay. Ano nga ulit ang formula ng change in time? Final time minus initial time. Ano po? Okay. Ang tinutukoy na after 2 hours and 21 minutes is the final time, no? Okay, because our initial time is still 0. From the beginning kasi yun. Okay, so 2 hours, 21 minutes. Did you get it?
Yes po.
Okay. Now, ang sabi, concentration initial, what will be the rate of formation, okay, of stannous phosphate if after 2 hours, okay? So 43.45 grams of it was formed, no? Okay, so after 2 hours daw, so we have 43.45 grams 45 in 654 milliliter solution.
Kung tutupo po namin yung mga concentration niya.
Of course.
Manila paper na talaga gagawin.
Manilang paper. But listen. Listen. Ang product kasi, sa simula, product kasi, di ba? Sa simula, wapa siya. Isn't it? Wapa. Wapa. Ang initial concentration nyo, wapa. Wapa. Isn't it? Kasi product ito, ano po? Pag product, ang initial concentration, laging 0. Okay? Pag product. Come again?
Ganun din po ba sa time?
Yes.
Sir, laging ganyan po yung nasa formula.
Laging 0 po yung time initial.
Pag product, yun na. Pag initial time sa 0. Pag sinabing from the beginning.
In the beginning.
Sir, parang
Okay. How do we compute for the molarity? So, sorry class. So, ibibigay ko na sa inyo ang molarity na sa test nyo. Remember that that is the weight over the molecular weight times the volume in liters. Can I say that this is 0.654 liters? Okay, so what we are looking for is the molecular weight of SN3PO4. Did you get it? Okay. Again, I will just give the molecular weight. Don't you worry. 16 by 16 is how many?
156.
Okay. I hope you will follow that I will put 4 for phosphoric acid times 31. 124 by ito. Okay. Ang tin ay 3 times 119. 357 ganito. And the answer is 737. So therefore, we can compute for the final molarity of SN3PO4. So that is 43.45 grams. Can you follow? Divided by 737 grams per mole. So times the volume in liters, so 0.654 liter. Canceling out the grams, so therefore the final molarity is 0.0901 molar. Ganire ha, ganire. Sige. Nagsisimula pa lang tayo.
Sir, ayun po yung final po.
Papunta pa lang tayo sa exciting part.
Sir, yan po.
Ha? Number 1 pa lang ito. Number 1 pa lang, class, ha?
Sir, yung go po. Sabi sa third. Sir, dapat third.
Ano yun? Ano daw? Actually, nung una sa second year, ang analytical chemistry.
Sir,
Okay.
for connecting yung SF yung final po na
Pinatay kayo dito.
So therefore, hi, are you still listening?
Yes po.
We can now compute for the change in concentration of SN3PO44. The final concentration is 0.0901 minus 0. Isn't it?
So yun na
Okay. And this is still 0.0901 molar.
Yan na po yun.
Sir, saan galing?
Hindi pa. Ano yun? Saan galing ang?
Ay, dun sir, galing na siya.
Yeah, 0. Kasi final minus initial.
So ikaw, yung time with 2 minutes, 2 hours, 21 minutes.
Ay, yung iba dyan, hindi na nakikinig. Okay, time! Wait a minute, class. Ang sabi kasi, ang nire-require sa atin, molar per minute. So, dapat yung time natin,
Gawin na.
minute. Okay. So, yung 2 hours, i-convert natin into minute first. So, 2 hours is equal to how many hour in minute? Or how many minutes in hour?
60.
Okay, so 60 minutes. 1 hour. So, how many minutes ito? 120. Pero meron pa tayong 21 minutes. So, therefore, 141 minutes. Did you get it?
Yes po.
Okay. So, therefore, the delta T is the final time, 141 minutes, minus 0 minutes, is still 141 minutes.
Yan na yun, sir.
Hindi pa. Kasi, itong dalawa, isa-substitute pa natin dito.
Okay.
So, in order for us to do that, the change in the concentration is 0.0901 molar. Can you follow?
Yes, po.
Divided by 141 minutes is how many?
0.0000.
0.0006 3 9 molar per minute.
Yun na yun, sir.
I-convert muna natin ito scientific notation with significant figures.
6.39
6.39 times 10
Negative
negative 4 molar per
Yun na
minute.
yun, sir.
Yes!
Tapos na, we
Tapos na ang number 1.
Sir,
Sige lang, go lang. Hindi pwedeng tama na.
Next week, is like walang yun, no?
Sir, laboratory ba or
Lecture.
May dapat tayo. Mag-compute nito.
Okay, paminalans ko na yung pangalawa, oh.
Yay!
Balance ko na.
Balance na din po niya sa quiz.
Oo nga, sabi ko nga,
Yes.
I might give balance equation in your
Mag-avoid tayo. Wala. Okay.
Ay, pasalimutan ko na. Wala lang. Nagtatrabaho ka ako.
Nababasa mo lang isip.
May ROTC pa kami ng Sunday. Buti nga kayo, wala kayong ROTC ng Sunday.
Parang alam ko din course mo.
Oo. Ganon. Malalaman niyo kung ano ng edad ko. Okay.
Uy! Sir, kami ko dito.
Lagi lang tatandaan class sa pag tayo nag-compute ng kinetics, lagi lang natin tinatandaan, pag sinabi natin change in concentration, it is always the final minus the initial. And the change in time is simply final minus initial. Ito yung ginagamit sa numerator. Ito yung sa denominator. Is that clear?
Yes.
Lagi lang natin tatandaan. Kasi pag sinabing change, nabago. No? So, nagbago. Is that clear?
Yes.
Okay. Basta ito class, no? Alam niyo lang itong dalawa, balik lang. Kaya. Ano pa?
Sir, kanina po sinabi niyo ng D1.
Sige. Apply natin yun. I-apply din natin ito class sa lab, ha? Okay, so let me see number 2. You have there the balance equation. 5Fe2SO43 plus 2 Bi3 and 5 will produce 10 FEN plus 3 Bi 2 SO4 5. Hindi naman class tinatanong yung mga formula ng rate. Ganyan pala. Pero isulat na natin. Okay? Sige nga. Dito sa Fe2 SO43, ano kaya ang formula ng kanyang rate? Negative change in concentration of Fe2 SO43. Ganyan pala. Divided by 5 delta T. Did you get it?
Yes.
Okay. BIN3 and 5. Ano nga? Change over. Okay. Did you get that? Wala lang na pala. O plus, ganun lang ang ito ang inilalagay dito at ito ang inilalagay dito. No? Sige. Madali na? Okay. FEN. Paligta. that clear? Okay. Sige. Para balik tayo sa more systematic, maglagay tayo ng given. Ha? BI3 and 5 was found to be consumed at a rate of 2.36 molar per second. Okay, so that is the rate. .36 molar per second. How many hours required? How many hours? That means the final time elapsed. Nangyari na, no? So, kaya final time. Kaya elapsed kasi. If only 0.56 BI3 and 5 was left, from the initial concentration, you look at that, 0.56 m was left. Anong ibig sabihin?
Final.
Okay. The final concentration, or should we say ganito na lang, no?
There's a given po yan.
Yeah, it's a given. So, concentration of BI3 and 5 final is equal to 0.56 molar, while the concentration of BI3 and 5 initial is how many? 3.72. Meron ba tayong nire-require na unit of time? Hours. No? Okay. Nakikita naman natin kung paano isasolve. Sige. Okay, so ilagay na natin ang solution. So ilagay na natin ang formula ng rate ng BI 3 and 5. I hope you can follow. Okay. BI 3 and 5 is equal to minus delta BI 3 and 5 divided by 2 delta T. Did you get it?
Yes.
That is our working formula. Why? Are you still with me? Bakit ito? Ito kasi tinatanong, di ba class? Okay. Inilagay lang natin ito kanina para lang ipakita natin yung ginawa natin before. Ano po? Pero, ang kailangan lang talaga natin ay ito lang. Is that clear? Okay. However, ang kailangan daw natin ay TF. So sa makatuwid, kailangan muna natin makuha ito, isn't it? Okay. Doon lang tayo magpo-cross multiply. Did you get it? Negative BI3 and 5. Can you follow? Is equal to the rate of BI3 and 5 times 2 delta T. Igaganon ko na lang siya. Ano po? Since kailangan natin yung 2 delta T, or yung delta T, we will divide it dito sa dalawa. Did you get it? So rate BI3 and 5 times 2 Did you get it? Okay. So rate.
Pwede mo po ulit, sir.
Okay. Ang kailangan natin ay delta T. Isn't it that? Kung ano yung katabi ng delta T, doon natin i-divide. Isn't it? Okay. So rate of BI3 and 5 times 2. Did you get that? Cancel, 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 cancel. Isn't it? Okay. Therefore, the formula for delta T, can you follow?
Yes.
Is negative BI 3 and 5. Can you follow?
Just go.
Divided by, unahin ko na muna yung 2. Okay lang ba? Unahin ko lang yung 2. So, rate of BI 3 and 5. Plus, para lang tayong nag-derive sa concentration, di ba, class? Ganun lang din yun, di ba, class? Tapos, pag na-derive na natin, substitute na. Mas mahirap pa nga yung derivation sa concentration, di ba, class? Di ba? Uy! Tingnan nyo nga yan, oh. Tatlo lang ito, samantalang doon sa concentration ng molarity, meron pa kayong molecular weight, meron pa kayong volume, meron pa kayong weight, di ba, class? Eh, ito naman, tatlo lang. 1, 2, 3 lang. Sa molarity, may weight, may molecular weight, may liter. O sino mas nandira?
Ayan po.
Yes.
Ang dami po kasi yung
Sir,
rate
sir,
formula.
kanina na pwede po ulit po yung ano.
Yun.
Substitute.
Ang substitute. What do you mean substitute? Multiplication.
Ay, possible.
The cross multiplication. Sige. Again, this is the formula that we have. And since we need this, cross multiply, isn't it? Pwede ba yung ginagawa natin sa concentration? Sige. At tapos, ma-cross multiply na natin, naging ganito na siya, no? Okay, so ito na. So, but since ang kailangan natin delta T, kailangan matanggal yung katabi ni delta T, isn't it? Kaya dinivide natin sa rate at saka sa 2, parehas side, para makancel natin yung 2 at saka yung rate. So, kaya naman, ang naging formula natin ay ganito. Did you get it? Okay, sige.
Ito na po palo.
Yes. Ayan na ha. Inuna ko lang yung 2. Okay? Parehas lang naman yun. Kanina kasi nasa dulo yung 2. Binaliktad ko lang, no? Okay, so pero ganun pa rin yun. Is that clear?
Yes po.
Meron tayo nito. Meron din tayo nito. Okay? So there, yes.
Hindi po yung rate sa baba.
Ayan. Yeah. Yes. Rate. And then meron tayo nito, no? Okay. Sige. Yes. Okay, so remember that the change in the concentration of BI3 and 5 is equal to BI3 and 5 final minus BI3 and 5 initial. Isn't it? Okay, sige. Yes. O, sige. Can you follow, ha? Okay. O, ano yung value ng final? Yung initial. Ilan?
Negative
1.6? Ganyan?
Yes.
Okay, so negative 3.16 molar. Tapos na ba?
Di ba po?
Siyempre hindi pa. equal to Can we now substitute the value of this? Okay. So, negative, ano yan?
Negative
3.16. Negative. Ano kaya ibig sabihin?
Positive.
Okay. Can you follow?
Yes po.
Divided by 2. Ano daw yung rate?
2.26.
2.36 molar per second.
4.7.
Can you follow?
Yes po.
Pwede ko na ba ito i-cancel?
Yes po.
Di ba yung second pupunta doon?
Yes.
Okay. Ilang second ang natitira? 4.72.
72.
Tama ba ang sagot natin? Ito, anong ibig sabihin nito? Positive na tayo sa net?
Yes po.
Okay, so and then ito, pag multiplyin. Ito ba ang sagot? 4.72.
Hindi po. Hindi pa.
For here lang, ang delta T. Okay. Yung ba? 4.72? Okay. Pero, ang tanong ay TF. But isn't it that the delta TF, or the delta T, yes. Alin?
So, ano mo ngayon sa 3.60 po?
Ay, alin? Oo. Tapos
Pero ano
i-divide
po
mo
ngayon?
ito.
Kasi,
Ano yun?
paano na po nga yung 4.7?
Ay, sabi niyo ito ang sagot. O, divide niyo ulit. 3.16 divided by 2 times 2.36. Sabi niyo sa akin yun ang sagot. Ganun ba? O, ay anong sagot? Tinatanong ko kayo kung pare-pares tayo ng sagot.
4.67.
Ilan?
4.67.
Ah, sige. Eh, kayo sumagot niyo eh. Ah, sige. O, para lang pala yun doon. Parehas ba tayo ng sagot? Paki-process ulit sa scientific calculator. Ito positive na, isn't it? 3.16 divided by open parenthesis 2 times 2.36 close parenthesis. At pagka na-equal 0.67 nga ba? Tama? Parehas na tayo? Okay. But remember that the delta T is TF minus TI. Okay? So for us to get the TF, okay, so we will simply change or transpose this over there. Did you get it? Okay, so therefore TF is equal to delta T plus T1. Kaya lang, at the beginning daw, di ba? Okay, anong T1 kunin natin doon? 0, kasi at the beginning, no? Okay, so this is 0.67 second plus 0 second. Isn't it? Okay, and this is still 0.67 seconds. However, we are asked in terms of hour. How many seconds are there in an hour? 3,600 seconds in 1 hour. Okay. So how many hours are there?
0.0001.
0.00. Isa pang 0. 186 hour. May 1 pa? Okay. So in scientific notation containing 3 significant figures, that is 1.86 times 10 to the negative 4 hour. Di ba ang bilis niyan, class? 0.67 seconds lang ang bilis-bilis.
Ika-calculate po namin na sa lab.
Yan na
Pag nag-experiment ako,
Yes. Yes. Class, you look at this. You look at this.
letter A pa lang yun. Letter A pa lang.
reaction na ito. Ito daw reaction na to. Ganong kabilis. Isang iklap lang, di ba, class? Wala pang isang segundo. Napakabilis ng reaction na ito. Iyon ang sinasabi sa computation natin kasi 0.67 seconds lang. Parang pumindat lang kayo noon. Baka mas matagal pa yung pindat nyo, ano? Okay, so kaya, from that, nakita natin ang bilis ng reaction. No? Okay. Nakapit tayo sa bilis-bilis lang naman pala. Ganun lang naman pala. Para lang tayong pumikit. Okay.
May lolo pa. May lo. May Sprite. Aray ko. Sir, 1 or 2 option.
Ay, may lang pa tayo.
Sir, naman ako kasi sa oras na lang.
Ay, isang nasa lang pala. On Saturday, for the lecture, will start from delusion up to
Wow! I love that.
That is for your lecture only. Yes. Ano yun? February 17 pala. Wala pa lang pasok.